Okay, so next step's going to be Edward Weber from Red Hat, Christian Browner from Incremental talking about optimized container live migration.
Yeah, as Stefan said, Adrian and I worked together on bringing optimized container-led migration to LXD and Flexi, and we're going to talk about how much fun we had while doing this.
So, first slide, those are the results. So, at the end, we try to make sure that it actually helps what we did. And the red bars are the optimized container migration, and the blue bars are the unoptimized container migration, live migration, and the scale is seconds. So you see for our different test cases, all time the optimized case was better than the unoptimized case. I will go into details about our test cases and all the setup at the end, but I just wanted to start with the results that it actually makes sense what we tried to do. And now you.
Right. So this is just a recap. I'm not going to go into this in any depth because you heard about this a bunch today. So we did this using LXD, which is the system container manager that sits on top of Flexi, which is just a shared library. And the shared library actually does all of the heavy lifting for live migration. It has an API that's based on CRIU essentially. And what LXD allows you to do by default, and this is all on Tycho, who gave a talk before, is that you can already move containers or live migrate containers between different LXD instances. We have this command called LXD move, and if your container is running and you send it to a remote LXD running on a different host, you can perform live migration. Meaning, who is familiar with the concept of live migration? Okay, cool. So it's basically just you dumping all of the volatile state to disk, you sync over the file system, and then you sync over the volatile state, you restore the task on the receiving system, and you're good. Yeah, exactly. So the idea is, as I said before, it's based on LXD Checkpoint. LXD Checkpoint is the implementation in the low-level library, and it's based on CRIU. So Checkpoint restore a user space where you snapshot a process. You can imagine it like this: dump its memory state to disk, and then you restore it to the exact state of execution where you snapshotted it. That's, so to speak, the idea, which is a great use case for example databases. Any kind of scenario where you're really interested in the volatile state of a given process or a process tree. And the migration steps for a container that you move with LXD move, for example, in this case, is you sync the file system while the container is running. You dump all the processes using CRIU, which stops the container, and this is crucial. Then you transfer all of the volatile states, so everything you dump with disk to disk with CRIU, and then you do a final file system sync, and then you restart the container on the destination, restoring all its volatile state using CRIU again. And the thing is, all of these three steps, using CRIU to dump the process, transfer the CRIU dump, and transfer the file system, in all of these three steps, the container is stopped. So the migration time actually depends on the memory size of the process. This is due to CRIU and how long it takes CRIU to take a snapshot of the given process. And then the file system change rate. So for example, if you have a lot of I/O on your on the host, on the source, and then you have to do a file system sync, you will obviously have to do a lot of I/O. So pre-copy is essentially a way, thanks, to optimize this process at least for the volatile state of a given process. The implementation basically it uses the soft 30-bit from the page table entry. So this basically just means every time a process writes to virtual memory, the kernel will set the soft 30-bit in the page table entry, at which point you basically know the memory of this page table entry has changed. So what you need to do is you clear the page table entry, and then you wait for the process to do anything interesting, and then you check the page table entry for the soft 30-bit again, and then you know that page has been written to. So what you do now is then you freeze the process, you dump the memory, the process can continue to run, and then you can transfer the memory state to the destination. And the trick is you only dump the memory changes which have changed. So you can do this iteratively, right? Every time the process changes, the memory changes, you dump it again, you transfer it again, but you can also use it to calculate a delta, basically meaning you say, given threshold n, when this threshold is reached, I want to do a final dump and then to transfer the rest of the memory state over, and then you can, for example, start with a file system or a final file system sync, and you're done.
And for completeness, we want to mention the other optimization CRIU offers. So CRIU does not only support pre-copy migration, you can also do post-copy migration. This is based on user forms and has been developed the last 2 years by Mike over there and me. And what you basically do, you freeze the process, you transfer only really a minimal state from one system to another. If you have a 100 megabyte process you want to live migrate, and the part which is not memory is like 200 kilobytes, so you transfer the 200 kilobytes, then you restart the process on the destination system, and once the process keeps running and hits a page which is not there yet, it forwards the page fault to user space, and user space can request the page from the other system and transfer the page to the other system, to the destination system, and the process can continue running until it hits another page which is missing. And so this is just for completeness. We didn't do it for this first round of optimizing container migration. And the optimal thing would be the combination of both. You first do multiple pre-dumps until you're satisfied with the amount of memory which has been transferred from the source system to the destination system. And at the end, the missing pages you are pulling over using lazy migration. So you have the best of both approaches and can hopefully decrease the container downtime even further. And like I said, we did pre-copy migration in our first approach. And what we actually did is we had first a look at the low-level library LXD, which we looked at, and the pre-copy migration support for LXD actually already existed, but as far as I know, it wasn't really used by anybody, and it was actually broken. So not the whole thing was broken, but some small parts around it, so we had to fix it. This was a quick fix and was not really difficult. And to go a step further, we implemented in the low-level library check if the current platform actually supports pre-copy migration support or pre-dumping. And the reason for this is this depends on many features. It actually depends on not really on the architecture, but on the kernel for that architecture, because not all kernel architectures are implementing the software ticket in the page table entry. Then it depends on the kernel version, if it actually knows about software ticket, and then it has to be enabled to support in the kernel, and then the CRIU version needs to be new enough to support pre-copy migration. And all these things can be luckily easily checked by just calling CRIU and asking for a certain feature. And we added this whole checking thing into LXD so that we can use it from LXD to detect if the currently running system actually supports pre-copy migration. So when this was done, we started to look at LXD and what we are currently doing to pre-copy migrate a container from one system to another. The first step is we check, like I described right now, if the underlying systems, both sides, support pre-copy migration. And if they do, then we check if the user didn't disable it, because right now if the platform supports pre-copy migration, LXD will always do pre-copy migration. And if the user dislikes it, he can still disable it, or because it's too slow or too much overhead or whatever. And then LXD does the first pre-dump of the so it still does all the steps it did before. It syncs the file system the first time, but then instead of doing the one dump of the container, it does the first pre-dump, and then we check if the percentage of pages which are unchanged during the pre-dump iteration are above a certain threshold. The default is 70%, so if 70% of the memory pages do not change, we do one final pre-dump and do the actual migration to the destination system. In addition to the threshold check, we have also another check to check the maximum amount of pre-copy cycles so that we don't get into an endless loop and do pre-copy cycles forever because the memory just changes too fast. And if both checks are true, then we move the container to the destination side. And those are the settings you can set to configure LXD to do pre-copy migration and how you want to do it. So the first one is to disable, enable pre-copy migration. The second one is the threshold in percentage to tell what memory needs to be the same before aborting in the last thing and how many pre-copy cycles you want to do. And I think the threshold is 70% and we do maximum 10 cycles. The user does not set it to a higher or lower number. So, and we were really happy. This was really cool that it worked, but we weren't really sure if it actually helps or if it makes things worse. So we were looking for a test case, and the test case was a bit complicated in the beginning to find because we wanted to see if the container downtime during migration actually decreases, and we wanted to see from the viewpoint of the container. So what we did, we have created a process in the container. It allocates 1 gigabyte of memory, and then it reads out the clock. It sleeps for 100 microseconds. It reads out the clock again, and then we compare those two values. And if it's lower than 400 microseconds, then we think we didn't sleep. We didn't miss one of our sleep cycles. And if it's higher than 400 microseconds, then something was missing and we could have been migrated. And if we do an actual migration, the number of missed sleep cycles is like 20,000, so we're missing a lot of cycles, so the number is really big there. But we can then read out that number from the logs and try to calculate backwards how much time the process was actually sleeping during the migration. And in addition to sleeping, we are also writing 1 byte in each memory page of the gigabyte of memory, and we either write no memory, so we just do the sleep cycle, or we write every memory, or we touch every memory page every second, every fourth memory page, and my testing was done on 2 VMs, and I have a short demo which I can show it. And it was using the latest LXD from Git, and that's where I come back to our results. And so the leftmost test case is the memory doesn't change at all. So you see, pre-copy migration is really good because we can do one dump while the container keeps on running and transfer the dump while the container keeps on running, and the actual downtime is really small because the delta we have to transfer is like, I don't know, a few Ks, and because the memory doesn't change. So this is completely a useless test case because it's unrealistic. We have a process which doesn't change its memory, but it's good as a baseline to know how fast it can be. And so if our test case is written correctly and we calculated the sleep time correctly backwards from the missing sleep cycles, the actual downtime goes down from like 22 seconds to 2 or 3 seconds, which is pretty nice. And the second column is we are changing every fourth byte. And the third is we're changing every fourth byte, every fourth memory page. The third is we're changing every second memory page. And the last is we're touching every memory page. And I actually don't know why pre-copy migration is better here. It should actually be worse, but maybe my test case was not perfect.
It was possible.
So we don't understand the last one, but the first three look really good, so we're happy there. And now, just an overview about the container runtimes. I have been working on to understand in how far they support container migration and optimized container migration. So LXD does now pre-copy supported container migration. RunC has support for pre-copy and post-copy, and a combination of both optimizations to migrate a container. From Docker, I only know they have some support from CRIU, but for container migration without any optimization, but I've never actually used it. And now for the demo. So what I have here is a container. It's L-time. It's really simple. And I say LXD move A1 to my another system, and I can put a time before. You don't see anything. It just moves the container and it's gone. And if I go to my other system and say, let's see the list now. Now it's here, and I can move it back again. I can. That's one here, and back here again. I can also enable pre-copy support. But unfortunately, this test container is so small that we don't see any difference. Takes the same time. But that's what it's about. It's not very interesting, but it works. I promise.
Questions?
Yeah, questions.
When you line migrate a container, what's to do about any TCP sessions or anything like that? Do they work?
Yes. So the test cases we did here was for containers without networking, but I've done container migration using RunC and TCP and Unity, of course. It doesn't matter. The IP address has to change the same. Has to be the same. If it changes, it doesn't work. It's the same if it works. I don't know. It works on LXD with it also works.
Well, no, as long as you need to make sure that both are connected to the same physical network, and CRIU will do the right thing. You might just need to wait for ARP to happen, so that's the traffic goes to the new machine. I think CRIU has some option to send an ARP packet, someone's got the hook or something like that, to just actually send a new packet to your switch saying, hey, I'm hitting ARP, so that you don't need to wait for the computer to hang up. So that copy doesn't work because you don't want to run the same code as it might be on two different machines. Yes. But move works. Yes. Other questions? Yes. Go up to over there.
I want to ask you, what is going on if one machine have time shift in seconds and minutes? I mean, the servers have a difference in time, and you restore container, and time is in the past or in the future?
So I would say this is only a problem of the applications running inside of the container. They are time sensitive for the container. At least I never thought about it, but I know there are applications which just stop because the time changes, but I've never seen any problems with process or container migration. You know something it looks like?
Business systems don't care.
Yeah, so I don't know the details how the TCP sessions are restored, what they do. Yeah, so yeah, that's really a good question, but I don't know. So whenever I used it, I never did it. Maybe my machines were synced in time, so, but I actually don't know how the host time relates to the TCP time. So I do. Yeah.
Hi, I'm curious. Out of the methods you proposed, first of all, I'm very interested in using this kind of stuff. But one thing which I was interested in is you mentioned databases, for example, as an example of something which you need to keep a lot of state. Another thing which is true about databases is they tend to have a lot of things like critical sections, places where if you have a page fault, things are pretty bad already. And unfortunately, what you proposed involves a page fault which could take on the order of like a ridiculous amount of time. So, is there any way that you can work to prioritize kind of these page faults which might end up occurring in critical sections?
So the question was that about user fault FD and the lazy migration. What happens if a page is missing that's really critical for the process?
I guess my question is, like, there are some things which are fine to lazily migrate. There are definitely some pages I definitely don't want lazily migrated. Like, if this page is not here, we should not be running. I saw you do have some controls, like this particular percent should be already there, but do you have, like, the application can specify through some kind of advisory, for example, if this is not here, I cannot run reasonably?
No, there's nothing like that. And we didn't do the lazy migration. This was just for completeness what CRIU can do. We only do pre-copy migration for the LXD integration.
Okay. As kind of a second part to that, I'm curious if you thought about using working set metrics to work out which pages might be worth prioritizing.
So I guess this is about CRIU's lazy migration support and how it actually works, right?
To some extent. I guess I'm mostly just curious, like, how CRIU selects the pages which are the most preferable to do the instant migration.
So currently it doesn't do, but this is a place where CRIU needs development to be smarter about its lazy migration algorithms. So right now it only does, you request something, we send it to you, and if it at some point nothing is requested, we just push all the other stuff to the destination.
Cool. All right, let's talk after about that.
And I think we're out of time. So thank you very much.